Right, so we're going to start our new unit, which is polynomials. The word poly means multiple, right? More than one, okay? Or one or more, okay? And nomials, they're the terms. So we're going to look at something that has multiple terms, okay? We're going to look at how to add them, how to subtract them, how to multiply them, okay? How to do this, how to collect like terms, and so on and so forth. So we're going to collect like terms, we're going to use the distributive law, expanding second degree polynomial and simplifying second degree polynomial. Okay? This is what we're going to do today's lesson. So what's a term? Let's start with the definition of a term. A term is something that has a letter and or a coefficient. So basically you'll have the term with a letter. So let's say the letter is x. Then you have a coefficient, let's say it's 3. And you could also have a degree with that. So you could have like a degree 2. So that's called a term. This is a term. 3 by itself. X by itself is a term. X squared is a term. Okay? XY is a term, right? So anything where you have a variable or two or more than a variable, coefficient, which is in this case your coefficient is 1, right? In these cases your coefficient is 1, and you could also have a degree, okay? Or you don't have to have a degree, it would be degree 1, okay? As long as the degree is a positive degree, so it could be 1, 2, 3, 4, right? It can be a negative degree, okay? So polynomials, they're terms that have variables to whole number exponent. So your exponent cannot be negative and it cannot be a fraction. Okay? So your exponent has to be 1, 2, 3, 4, 5, and so on and so forth. So if I look at this, 5x cubed, that is called a polynomial. All right? It's a polynomial because this term has a degree 3. The variable is x, and the degree is a whole number, and it's positive. This one. Why is this not a polynomial? 2x to the power of negative 1. Negative, right? If you have a negative exponent, it is not a polynomial. Okay? And here, that's the same thing as writing 7y to the power of negative 2. We can write it like this, or we can bring it down to the denominator and it becomes y to the power of 2. So that's also why this is not a polynomial, because technically, even if I don't look at this, your variable is in the denominator, okay? So it's not a polynomial. The variable has to be in the numerator, and it has to have a positive exponent, and it has to be a whole number, okay? What's a second degree polynomial? Second means 2, right? So that means the highest degree, the highest exponent is 2. So remember that in a term, so the term is going to have a coefficient, a variable, and then the exponent or the power or whatever you want to call it. Okay, so it could be exponent or power. Second degree polynomial, the power is going to be 2. Okay, the highest power that you're going to have is going to be power 2. So if you look at this, you have 3 terms, yes? So you have the first term, which is 7x squared, minus 4x plus 2. Your first term is a second degree polynomial, okay? Because your highest degree is degree 2. Do we understand that? What's the degree on this x? 2. What's the degree on this x? What's the degree here? 1. right? Well, how about here? Do you have an x? Technically, it's x to the power of 0, but we don't write it. Okay? So, what's the highest exponent that you have on all the x's? 2. And that's why it's called second degree. Because the highest exponent is 2. Okay? Now, the highest exponent is 2. That means that makes this number, which is the first coefficient, we call this the leading term or the leading coefficient. Okay? Leading term means the highest term with respect to the exponent. So if you look at all these three, you have 7x squared, and then you have 4x, and you have 2. Your highest exponent is the exponent 2. Yes? So that whole term, 7x squared, we call this the leading term. That's the first term. Okay? And then the 7 that comes right before the x squared, that's a coefficient of the leading term, which we call it the leading coefficient. Okay? Leading means the first. When we write the polynomial in math, we always write it in descending order of exponent. Okay? So let's say if I have this, if I have these terms, right? Highest exponent, then followed by the lower one, followed by the lower one, followed by the constant. They have to be in order. Okay? 3, 2, 1, 0. Make sense? Okay? And always the first one with the highest exponent is your leading one, is your leading term.
So it doesn't matter if the coefficient is lower?
Sorry?
Does it matter if the coefficient is lower?
No. Right? I can have this. Right? That is still my leading term. And leading coefficient. Your leading coefficient is going to be 2. So this is going to be your leading coefficient. Okay? And the whole thing is your leading term. Are we okay with that? Okay. Now, we're going to go to expanding using distributive property. Okay? So, the example that I always use is the combo example. Okay? So let's say you are you're going to the Taco Bell and then you want to order combos. Okay? And then your combos are you can get 2 taco at a pop. Okay? So let's say you want to get 2 tacos plus 1 pop. Okay? That's your combo. And then you're a family of 3, right? You want to order 3 combos. So how many tacos and how many pops are you going to get if you're a family of 3? 6 tacos and 3 pop. And how did you get that? Times it by 3, right? So you're going to take your combo and then you're going to multiply it by 3. Yes? So that would be 3 multiplied by the 2 to give you the 6, and then you're going to also multiply the 3 by the 1 to give you 3. Yes? Good. We're doing exactly the same thing. We call this a distributive property. Okay? But instead of tacos and pops, we have x's and y's, or we have x's and numbers. Okay? So if I look at this, this is 3 times x minus 4. Yes? So that's the same thing as writing 3 times x minus 4, but I don't write that times because it doesn't make any difference, right? Use less terms. So what I do here is, in order for me to get the answer, so we call this expand. Okay? What I do is I distribute. So I multiply that 3 by the x. What's 3 times x? 3x, right? and I multiply the 3 by the negative 4. So that's going to be negative 12. Right? So what we call here, what I used what we call the distributive property. So I'm distributing that 3 to every single term inside my bracket. Okay? So how about if I have 2y multiplied by 3y plus 2? Okay, so let's distribute. So what's 2y times 3y? 6. Now you have y times y. What's y times y? So because you're multiplying y by y, okay, if I have y times y, what would that be? How would I write that in more simple form? Y squared. Yes? So that's the same thing as writing y squared. Yeah? So that's going to be 6y squared. Yeah? Okay? And then? And then 4y, because if I multiply 2y by 2, that's going to be plus 4y. What degree is this? What's the highest degree that you see there? 2, right? And what's the leading coefficient? 6. The leading term is 6y squared. The leading coefficient is 6. Okay? And then the highest degree is 2. So it's going to be degree 2. Okay? So what I want you to do is I want you to try the support questions. Okay? So you can try this one, this one.
If it's just a negative, do you pretend it's a 1?
That's right. So if it's negative 3x plus 4, right? That's the same thing as negative 1, right?